All right, today we're going to dive into the math behind some seriously explosive growth. We're talking about geometric progressions. And once you get the hang of it, you'll see how a simple formula can help you predict everything from viral trends to how your investments might grow. So let's just jump right in.
So what do a virus and your bank account have in common? I know, it sounds like the start of a bad joke, right? But the answer actually points to this incredibly powerful pattern that's all around us. It's a kind of growth that can start off super small and then just become massive, almost overnight.
Okay, so look at these two types of growth. On the left, you've got this steady, predictable adding pattern. 1, 2, 3, 4. It's like taking one step at a time. But then you look at the right. Whoa, that's the power of multiplying. It starts out slow, but then it just takes off like a rocket ship. That explosive pattern is exactly what we're going to unpack.
So let's get a closer look at what's really going on here, this idea of growth by multiplying. Picture this. You have a virus. One person infects 2 other people. Okay, not so bad. But then those 2 each go on to infect 2 more. Now you've got 4 new cases. And those 4 infect 8, then 16. You can see how fast this thing explodes. It's a chain reaction, and that's the engine behind this kind of growth.
Now, this kind of pattern has a proper name. In math, we call it a geometric progression. The really important thing to remember is just this. There's one single, consistent number that you're multiplying by each time to push the sequence forward.
And that fixed number we just talked about, well, it's pretty much the secret ingredient to this whole thing. It's so crucial, in fact, that it gets its own special name.
We call it the common ratio, and we usually just write it as R. So think back to our virus example. 1 became 2, 2 became 4. What were we multiplying by each time? 2. So in that case, R was 2. And honestly, finding that R value is always the first step to cracking any of these sequences.
Okay, so sure, you could just keep multiplying over and over again to find, say, the 100th term in a sequence. But why would you? There's a much smarter way to do it. Let's break down the formula that does all the heavy lifting for us.
And here it is. I know, at first glance, a formula like this can look a little intimidating. But trust me, every single piece of it has a really simple logical job to do. With this one little recipe, you can find any term in the sequence, no matter how far down the line it is.
All right, let's pull it apart. First up is un. Think of this as your goal. It's the value of the term you're actually trying to find. So if you want the 10th term, you're solving for U10. Simple as that.
Next up, we've got A. A is simply the very first number in the sequence. It's your starting point. It's where the whole thing kicks off.
Then we have R, and you already know this one. That's our common ratio, the number we multiply by every single time. It's the real engine of the whole progression.
Okay, now for this last part, the n-1. This is actually pretty clever. Think about it. To get from the first term to the second term, you only have to multiply 1 time, right? To get to the third term, you multiply twice. You see the pattern? To get to any term n, you always make n-1 multiplication jumps. That's all that means.
All right, that's enough theory. Let's actually put this formula to the test and see how it works with a real-world problem.
So here's our problem. We've got a sequence, 3, 6, 12, 24. You can see pretty easily that it's just doubling each time. Our mission is to find the 6th term in this sequence. And instead of just doing it in our heads, we're going to use the formula.
Okay, let's plug in what we know. Our first term, A, is 3. The common ratio, R, what we multiply by, is 2. And the term we're looking for, N, is 6. So our formula becomes 3 times 2 to the power of, remember, n-1, so 6 minus 1 is 5. So that's 3 times 2 to the power 5, which is 3 times 32.
And that leaves us with our answer, 96. See, the formula gets us there perfectly. No guesswork needed at all.
So that's great for a quick math problem. But why does this actually matter? Like, where do these geometric progressions pop up in the real world?
Well, this is not just some abstract math concept. This is literally the engine behind compound interest in your bank account, the thing that makes your money grow over time. It's how scientists model population growth. And yeah, it's absolutely crucial for understanding how things like information or a virus can spread with such incredible speed. This pattern is everywhere once you know what to look for.
The thing is, this type of growth happens so fast that you really can't just eyeball it or guess. So this formula, it's not just a handy shortcut. It's actually an essential tool if you want to accurately track and predict these incredibly powerful patterns.
So, we now have this amazing tool to find any single point in that massive explosion of growth. But it makes you wonder, right? What if you wanted to know the total of all the steps combined? How could you possibly add up a series of numbers that are growing that fast? Well, that is a fantastic question for another time.